Okay.
Okay.
Hello, Bruno.
Hello.
This is another episode of Hydrogen in 3, and we're fortunate enough to have Bruno here today, who I will allow to make an introduction, but a leading pioneer and professional in the hydrogen space who's been working in H2 for quite a long time now. And obviously, as the market picks up, it's very interesting to get him on here and get his insight. So first of all, Bruno, if you would like to introduce yourself, explain a little bit about your background and sort of where you see hydrogen, developing over the next sort of year or so.
Sure. Thank you very much indeed for your kind invitation. So my name is Bruno Pollet. I'm the president of the Green Hydrogen Division of the International Association for Hydrogen Energy. I'm also director of the Green Hydrogen Lab and the deputy director of the Research Hydrogen Institute at the University of Quebec at Trois-Rivières in Canada.
Excellent. And I mean, in terms of for the broad goals for reaching net zero, what role do you specifically see from your experience hydrogen playing in that trajectory?
I mean, as you said earlier on, I've been in this business, so this hydrogen for quite some time now, and it's now very clear that hydrogen has a central role in helping the world reach net zero emissions by 2050 and limit global warming to 1.5 degrees Celsius. And as we know, like in many regions of the world, to reach net zero carbon by 2050, the main focus is on targeted industries, on sectors difficult to decarbonize, the so-called, the hard to decarbonize sectors or hard to electrify sectors, especially the energy-intensive industry like iron, steel, mineral, chemical processing, commodity chemicals, fertilizers, heavy-duty transportation, such as freight trucking, shipping, and aviation. So actually, from today through 2050, hydrogen could eventually avoid around 80 to 100 gigaton of cumulative CO2 emissions, with more or less an annual abatement potential of 7 gigaton in 2050. This means that hydrogen can contribute to around 20% to 25% of the total abatement required in 2050. But so to achieve this ambitious objective or goal, this requires the use of around 700 million metric tons of renewable and low carbon hydrogen in 2050, which is equivalent to nearly a quarter of the global final energy demand.
Yeah, I mean, it's definitely something that's going to be more prevalent as these years move on as well. I mean, people will have foreseen this kind of movement, people like you who've worked in the industry for a while, but I think, people working around the sector or keeping ear to energy will have seen major partnerships and investments and MOUs over the last couple of years, especially. Obviously in our space, working in recruitment and consultancy, that's something we keep an eye to.
Yes.
But what do you think is the real positive of those sort of things happening? And what do you think are the main challenges that the sector faces coming up with a lot of the changes for the sector in general?
Sure. I mean, for me, the big positive here is that hydrogen is now taken very seriously.
Yeah.
Okay. And this is the good news. And it's very important at that time now that partnership from all sectors are forged quickly to achieve the 2050 decarbonization targets. Moreover, we all know we are going through an energy crisis. And I strongly believe that hydrogen will play even more an important role in this energy transition. This is an important pivotal time where hydrogen can be deployed very quickly in all sectors. However, there is a great need for more investment for constructing a clean hydrogen infrastructure, as well as actioning for implementation of the various global hydrogen strategies. It is paramount to scale up, i.e. to think big, implement fast. We need to ramp up our activities in this sector. We also need to ensure the supply chains across the hydrogen value chain are ready. Training programs and the trained skill force are also ready. Very important. Also, the other challenge is the fast deployment and installation of electrolyzer and renewable capacities for the production of renewable hydrogen. So as an example, the global demand for hydrogen electrolyzers in 2030 will be around 6 times higher than available supply. This means that more than 400 gigawatts of electrolyzer will be required by the end of the decade. Only, we'll have about 70 gigawatts will be manufactured by then. So we need to ramp up rapidly this sector. Lastly, and I always say that, we need to keep investing in R&D. The large R&D funding across the whole hydrogen value chain is also urgently needed to validate the new technologies and generate innovation, IP, new industries, as well as training the next generation of hydrogen scientists and technologists.
And I think that's why it's very interesting to have you speak on here from a slightly different perspective to some other people working in hydrogen. The geographical locations and different organizations are all at very different stages within, the value chain of hydrogen at the moment. And I think recent developments might mean that maybe countries or organizations that were less keen to push the hydrogen agenda are now being forced to do so because they realize it's not only a bridge, but it's, it could be the holy grail for, energy.
Right.
And I think
that's right.
That leads me to my last question. You mentioned the need to continue investing into research and development, but what role do you think that the research sector in general within hydrogen, and also the companies that you represent and the organizations you're involved in, will play, particularly in 2022 and beyond in the near future? How do you think how important do you think those will be in the development of hydrogen?
Sure. First of all, I'm very lucky because I've got one foot in industry and one foot in academia, so I can bridge really the gap between the two entities. So I'm there to solve it in a way the industry problems, and I've got my team within my university or research institute to actually try to solve those problems. And I actually very recently have been awarded 2 research chairs by the Canadian government and the Quebec government to develop the next generation of electrolyzers with a particular focus on innovating on low-cost materials and systems. So, the main objectives of my research programs is to develop electrolyzers which will be 50% less expensive than the existing ones. As we all know, they are still expensive, this electrolyzer. If you look at PEM, alkaline, or even high temperature electrolyzer, we need to reduce the capex, and more importantly, also we need to look at in more detail the OPEX as well. Okay, so my team and I at the Green Hydrogen Lab at the Hydrogen Research Institute, we contribute to this hydrogen value chain. Okay,
definitely, and I think that's a very good insight for us to have, and I look forward to everyone seeing this. And that's all from me, Bruno, and I just want to say thank you very much. And obviously all the endeavors you're involved in are contributing towards a goal that we're all involved in too. So thank you for that, for your continued involvement and sort of championing hydrogen. And I wish you all the best in the near future.
Thank you very much. Thank you very much.